So basically, for today, right, we have to do aldol condensation. Now, just understand what aldol condensation is, right? What aldol condensation is, right? Now, just have a look what is happening. When we are talking about the aldol condensation, right? So you understand, aldol condensation is a very important, you know, aldol condensation is a very important reaction for for the aldehydes. It's a very important reaction for the aldehydes and ketones. Okay? It's a very important reaction for the aldehydes and ketones where where there is an alpha H. Where there is an alpha H. Yes or no? Okay, now let me just tell you. Now, what do you mean by an alpha H? Just understand. When we are talking about CH3, C double bond O and H. I hope you're understanding this is an aldehyde. C double bond O and H,
Yes, ma'am.
right? Now, when this is an aldehyde, right? So just have a look. So this H, C double bond O group is there. And when we have the C double bond O group, yes or no? So what exactly is
Yes.
happening that there is the CH3 connected to this. So just besides the C double bond O, there is this CH3 group. So this carbon just at the next carbon, just the next carbon of C double bond O is called as an alpha carbon. You understand? So when this is called as
Yes.
an alpha carbon, what do you understand from this? This alpha carbon has few hydrogens connected with it. These are the hydrogens, right? So when these are the hydrogens, I hope you're understanding these hydrogens connected to the alpha carbon is called as alpha hydrogen. You understand? So this is an alpha hydrogen. This is an alpha hydrogen. Understood or not?
Yes.
So when we have this alpha hydrogen and alpha hydrogen, so C double bond O group is there and just next carbon to C double bond O, provided that carbon should be a sp3 hybridized carbon. What do you mean by an sp3 hybridized carbon? Understand? What do you mean by an sp3 hybridized carbon? Which is
Two by.
forming four sigma bonds. Which is forming four sigma bonds. I hope you're understanding. Right?
Yes.
So such a carbon is called as an alpha carbon. Understood?
Yes, ma'am.
Right? And we need to have at least one. We need to have at least one alpha hydrogen. Are you understanding? This needs to be there. One alpha hydrogen needs to be there. Only then aldol condensation could be done. Now, what is the meaning of aldol? When I say aldol, that means it is talking about the product. The product so formed should be of the aldol type, aldehyde and alcohol. Aldehyde and alcohol. You understand? So aldehyde is
Yes.
ald, aldehyde. Ald word has come from aldehyde. And alcohol, the word ol has come from ol. You understand? So this is how the word aldol has been formed. And this name we have given to this reaction based upon the kind of product that is being formed. So the kind of product that is being formed is aldol. You understand? The kind of product that is being formed is aldol. So that compound, the product shall have an aldehyde group as well as the product shall have an alcoholic group. So that is what the name of the complex is, aldol condensation. You understand? Now, what exactly is
Yes, ma'am.
happening in this aldol condensation? Just have a look. Just have a look. So when, for example, when we write down aldol condensation, so today we're going to do a simple aldol condensation. A simple aldol condensation. When we are talking about the simple aldol condensation, what exactly does that mean? Just understand. When we talk about a simple aldol condensation, just understand that, let's talk. It includes two molecules of the same type, two molecules of aldehyde, or two molecules of the same ketone to undergo condensation. That is what you understand by the term simple aldol. Okay, so two molecules of aldehyde or ketone to undergo condensation, to undergo condensation is called simple aldol condensation. Is called simple aldol condensation. You understand? So basically,
Yes.
what exactly is happening? Just understand. So when we are talking about CH3, C double bond O and H, right? And let me elaborate these hydrogens here on this carbon. So I will say the very first question that is being framed on this particular compound is that these alpha hydrogens, this alpha hydrogen, this alpha hydrogen, and this alpha hydrogen. Number one, a very important point, that alpha hydrogens are acidic. First point. Second point to understand is that alpha hydrogens, when are removed from the molecule, leave behind a carbon ion, leave behind a carbon ion. Okay, they leave behind a carbon ion. That's very, very important. So when we are talking about the alpha hydrogen, so you will say that, when they are removed from the molecule, they leave behind a carbon ion. Now, what exactly does this carbon ion mean? You understand? So, and this question, every question has a why. That we know why it is acidic. Why does it leave behind a carbon ion? You can remember them as a property also, but there is a reason behind that also. So, for example, just understand we have this particular, one hydrogen. I'm going to write it down like this. So, let us suppose there is this OH negative ion, and OH negative ion is a base, and bases are always looking for what? Bases are always looking for the bases are always looking for H plus. So this OH negative goes and attacks this hydrogen. Why so? Because carbon's electronegativity is 2.4. Carbon's electronegativity is 2.4. Yes or no? And hydrogen's
Yes.
electronegativity is 2.1. So when carbon's electronegativity is 2.4 and hydrogen's electronegativity is 2.1, I hope you're understanding that this OH negative is going to pull H plus, because both the electrons will remain towards carbon. One towards carbon, and the blue electron will also be towards carbon. Because I hope you're understanding that this hydrogen has one blue electron in the bond, and this dot carbon is actually another electron in the bond. So this OH negative shall be, taking all the structure. So this OH negative is going to do what? It is going to take up this electron. And we will have OH negative combining with H plus. So what do you think the product shall be? The product shall be H2O. Yes or no? The product shall be
Yes.
H2O. And what am I left with then? You just see, what am I left with then? I am left with CH2 negative, because this negative charge is coming from this blue extra electron, and C double bond O and H. You understand? So this is the structure
Yes.
that we have. So we have CH2 negative and C double bond O H. Understood or not? So I hope
Yes.
you're understanding that, when we are talking about this particular CH2 negative and C double bond OH, this carbon ion is left behind first of all. So you understand that carbon ion is left behind. Carbon ion is left behind. What is carbon ion? The carbon carrying a negative charge. So this carbon is carrying a negative charge. You understand? So you have to
Yes.
understand that whenever what do we say? That, simple aldol condensation takes place in the presence of dilute NaOH. Takes place in the presence of dilute NaOH. So my point is that if it is taking place in the presence of dilute NaOH, what is NaOH? NaOH is a base. I could have used dilute KOH. I could have used dilute barium hydroxide. I hope you're understanding. I could have
Yes.
used any base. You understand? I could have used any base. So basically, the base, what is that base going to do? Just tell me. That base is going to extract the alpha H, because that base is going to give you OH negative ion, and that OH negative ion is going to give you H plus. It's going to take away the H plus, and which H plus? the H plus of the carbon which is just connected next to the C double bond group. So C double bond group is the main carbon, which is the carbonyl group, and the carbon next to that carbon is my alpha carbon. And to that alpha carbon, the hydrogens which are connected are acidic. So the OH negative, which is coming from the base at the very first step, will take away that H plus, leaving behind a carbon ion. Are you understanding? Yes or no?
Yes.
And this negative charge will do what? This negative charge will now find a way to stabilize itself and it will undergo resonance. So you see, resonance occurs in a conjugated structure. So negative goes towards this carbon because negative single bond double bond. You understand, this is a conjugated structure. Double single lone pair, double single lone pair, double single lone pair. You understand my point? So when
Yes.
this negative charge comes here to resonate, what does it exactly does? What does it exactly do? You understand? It is going to be under resonance and it is going to form this. It is going to form CH2 double bond C O negative and H. And this resonance basically stabilizes what? This resonance basically stabilizes the carbon ion. Okay? This resonance basically stabilizes the carbon ion. I hope you're understanding. The carbon ion is right here. The carbon ion is right here. So this negative charge would stabilize itself. And you understand that, O is highly electronegative. So this negative charge is going to be held very tightly because I hope you're understanding that this negative charge is nothing but just a pair of two electrons. And these electrons are held tightly by oxygen because oxygen is highly electronegative. So the nature of oxygen is to what? To hold the electrons, to not give, but to keep electrons towards itself. So it is going to keep electrons towards itself, and I will say that stabilizes the carbon ion whom? O negative stabilizes the carbon ion because a a negative charge is more stable on oxygen. Yes or no? A negative charge is
Yes.
more stable on oxygen. I hope you're understanding. So this is the concept. So
Yes, ma'am.
when we are talking about the simple aldol condensation, dilute NaOH, KOH, BaOH whole twice, I hope you're understanding that this shall be my concept. So I hope you're understanding that alpha H is acidic. The what is the base doing? Base is releasing OH negative, and that OH negative is pulling off the H plus. And when that is pulling off the H plus, so there is a negative charge on this particular carbon. And when there is a negative charge on this particular carbon, so it shall form CH2, C double bond O and H. Yes or no?
Yes, ma'am.
So what is going to be formed? It is going to be CH2 negative and double bond C and O negative and H. Yes or no?
Yes.
Now you see. Now this,
मैम
yes.
ये किसी भी बेस के साथ
Okay. Now you understand that when we have the CH2 negative, so this structure is actually being formed CH2 negative, C double bond O and H. So this has happened with the first aldehyde molecule. Okay. The very first molecule of aldehyde has actually undergone this kind of change. So why am I saying the very first molecule of aldehyde? Because you understand that you take a beaker and you add lots and lots of aldehyde into it. What kind of aldehyde? Aldehyde having alpha H. And you add a base. Simple. And you heat and you wait for the reaction to happen. So there are lots and lots of aldehyde molecules, isn't it? These are all aldehyde molecules. So is there one aldehyde molecule? No, there are many aldehyde molecules. And when we have many aldehyde molecules, I hope you're understanding that these aldehyde molecules for base, basically the first molecule of the base will react with one aldehyde molecule, and there might be another aldehyde molecule, the aldehyde molecule CH3CHO, which would again be exactly the same as we have added up. So that means nothing has happened with that molecule because that has not interacted with the base at all. I hope you're understanding. So this second molecule of OH, the aldehyde, is actually waiting for something to happen with it. And what is going to happen with it? You see this negative charge. So you understand the CO bond is a polar bond. This is a carbonyl bond. And carbonyl bond is a polar bond, isn't it? Carbonyl
Yes,
bond
ma'am.
is a polar bond. So this bond is going to open towards oxygen. Both the electrons are going to open towards oxygen because one bond is a sigma bond and another bond is a pi bond. And pi bond, is a weaker bond. Yes or no? Pi bond
Yes,
is a weaker bond. So obviously the weaker bond opens up. The weaker bond opens up towards the weaker bond opens up towards where? The weaker bond opens up towards O negative. So when it opens towards O negative, so carbon acquires a positive charge. Carbon acquires a positive charge. So which carbon? The carbon of second aldehyde molecule. So the structure shall be something like this. So this aldehyde, the red molecule will undergo this change and it will now look something like this and this. And the black molecule has been changed to the alkoxide ion, the aldehyde ion. Yes or no? So this ion is formed.
yes,
And now this black negative ion is going to make an attack on the positive charge of the red molecule. And why has this carbon acquired a positive charge? Because there is a O, the carbonyl bond opens up. So you understand what is condensation. The two molecules are now about to combine to form a final product. You understand? To form a final product, they would be combining like this: CH3, C, O negative, and this red H I'm writing down right here. And the black molecule of CH2 is here, and we will have CHO and like this. You understand my point? So do you understand that how these two red molecule of aldehyde and the black molecule of aldehyde, they have just condensed, they have just joined back. And I hope you remember in the previous slide, the OH negative had taken up with itself the H of the first aldehyde molecule, isn't it? This was my
yes,
first
right.
aldehyde molecule to form water. So first aldehyde molecule, yes or no? So when it had taken that first molecule of water or first molecule of aldehyde, so I hope you're understanding that this H2O, the H2O, we have OH negative and we have the H plus. So they combined basically to form water. The OH came from the base and H plus it has extracted from the first aldehyde molecule. So water was formed. And now you see how does it actually changes. This O negative, the red O negative, it goes back to that water molecule and takes away this H plus back. It says that this H plus belongs to our aldehyde family, return it back to us. So what is the final product that we're going to get? We're going to get CH3, C, H, O negative, gets back its own H, and the other black molecule of aldehyde adds up like this. And this is my final product. You understand? This is going to be my alpha, this is going to be my main carbon, my carbonyl group. So next carbon to that would be alpha carbon, and next to that shall be beta carbon. I hope you're understanding. You understand my point.
Yes, sir.
What does that mean exactly? You see, so there is a beta OH, and there is a aldehyde group, the main carbonyl group, the main functional group. So you have two groups in the same structure. So this is going to be my aldehyde group, and this is going to be my beta OH group. So my final product shall be alpha beta. So my final product shall be beta hydroxy aldehydes. Beta hydroxy aldehyde. Yes or no? It shall be beta hydroxy aldehyde. I hope you're understanding. Yes or no? Why beta hydroxy? Because alpha is carbon. Alpha carbon is that carbon which is very much next to the carbonyl group. CO group is called carbonyl group. So very next to alpha carbon is the CH2 group. And just next to the alpha carbon would be my beta carbon. So beta carbon has OH connected onto it. So I hope you're understanding that we have the OH connected, and OH group is also called as the hydroxy group. Are you understanding my point?
Yes,
Okay, so that is the concept. That is the concept. So I hope you're understanding that when we are having this final product be formed. So what is condensation? Condensation basically means the joining. Condensation basically means the joining. You know, the joining of two aldehyde molecules in the presence of base. The joining of two aldehyde molecules in the presence of base. In the presence of base. Are you understanding my point? Okay, that
yes,
is the concept. That is the concept. Understood or not?
yes,
Correct. So that's how basically we work along the aldehyde. This is going to be my, the aldol condensation. But the necessary requirement is the presence of an alpha H and a base. So how would you write down this equation? You will write it down that, ma'am, I have this CH3, CHO, and two molecules of this in the presence of dilute NaOH to form this final product CH3, COH, right? And H and CH2 and CHO. So this shall be my final product. So how would I name this compound? It shall be 1, 2, 3, 4. So 4 carbons in the main chain. So I will call it as butanal. I will call it as butanal. And on the second, third carbon, I will say 3 hydroxy, 3 hydroxy butanal. So now you understand why it is an aldol condensation now. Because the main compound is an aldehyde. But it also has the ol group. Ol group is what? The alcoholic group. Okay, so that is why we have CH3, COH, CH2, C double bond O, and the H. That's how we have 3 hydroxy butanal. Understood or not?
मैम बट मैं तो टू
ना ज्यादा जब भी हम नेमिंग करते हैं तो हम ये देखो, ये CHO ग्रुप दिख रहा है आपको नेमिंग करते समय, और ये OH ग्रुप दिख रहा है। तो जो ये CHO ग्रुप दिख रहा है, ये CHO ग्रुप बेसिकली एल्डिहाइड ग्रुप है, और एल्डिहाइड ग्रुप की नेमिंग करते समय, जब नेमिंग कभी करोगे ना, तो आपको समझ आएगा कि नेमिंग करते समय जो ये एल्डिहाइड ग्रुप है ना मेरा, इस एल्डिहाइड ग्रुप की प्रेफरेंस जो होती है ना, वो अल्कोहलिक ग्रुप पे ज्यादा होती है, which means that if in a particular group, if in a particular group we have both the CHO group and both the alcoholic group, so the compound will behave more like an aldehyde. So OH group does not show its properties to a larger extent. I hope you're understanding. So when CHO group does not shows its properties to a larger extent, or sorry, OH group does not shows its property to a larger extent. That means what? That this CHO group that we have will be main functional group. And whatever is the main functional group is actually suffixed. उसका नाम पीछे लग जाता है ऐसे. तो 1, 2, 3, 4 तो 4 कार्बन हुए. तो 4 कार्बन हुए तो ब्यूट वर्ड रूट बना, तो ब्यूटेनॉल बना. लेकिन ब्यूटेनॉल तो फर्स्ट कार्बन पे एल बना, लेकिन 1, 2, 3 थर्ड कार्बन पे तो OH आएगा ना. आप इसको और क्या लिख सकते हो? आप इसको लिख सकते हो बीटा हाइड्रोक्सी ब्यूटेनॉल. दैट इज आल्सो फाइन. बट बीटा लगाते ही दिस इज गोइंग टू बिकम द कॉमन नेम. आई होप यू आर अंडरस्टैंडिंग. बीटा लगाते ही this is going to become a common name. So as an IUPAC name, you have to write it down as, 3 hydroxy butanol. Understood or not?
yes
Yes or
yes
no? So that's how you are supposed to work with this. Nothing else. So this is the simple aldol condensation. I hope you're understanding my point.
yes
Right? This is the concept. This is the concept. So now similarly, if you write down the simple aldol condensation for, if you write down the simple aldol condensation for, let's suppose some ketone. So ketones also undergo aldol condensation. Let's take an example of this. So if I write down 2CH3COCH3, that is my acetone. Acetone is a common name, but it is actually 1, 2, 3. So word root shall be 3. So it shall become propanone. Yes or no? So here, what exactly is going to happen? Just tell me. Here, what exactly is going to happen? The CH3CO CH3. What does that exactly mean? You tell me. That would mean that when you're putting dilute KOH to that, KOH is a base. So step number 1, what would you write down? The mechanism shall be KOH shall break down. KOH shall give its own K plus and OH negative. And we have taken two such molecules of acetone, isn't it? So I will say, let's take an example of the first molecule. So the red molecule is my first molecule. So CH3CO CH3. And this is going to be my alpha carbon. This is going to be my alpha carbon. Why? Because both the alpha carbons are just next to carbonyl group. So there could be more than one alpha carbons. So you take up any one alpha hydrogen and you carry forward the reaction. So we have this, and we have this. So the OH negative that we have, that OH negative shall be sort of this. It is going to take away the alpha H because alpha H is acidic. And when it is acidic, so my red aldehyde shall become the ketone, shall become CH2 negative and C double bond O and CH3. And then it is going to attack on the second molecule of ketone, which is going to be the ketone molecule. And the black ketone molecule, the CO bond opens up. C acquires a positive charge, O acquires a negative charge, and this negative attacks from the positive end. The CH2 negative attacks the C plus, isn't it? So what shall be the product that is going to be formed? So it shall be CH3. So the black molecule shall be CH3, C, it shall be what? It shall be CH3, C, O, negative, CH2. And the red molecule will connect itself to CH2, C double bond O, and CH3. And O negative shall connect to OH. Because why it is going to connect to OH? Because the water that was actually, when these two were combining, right? These two were combining. So these two were combining to form what? These two were combining to form, this is how it was taking away with itself. So these two were combining to form water. And when these two were combining to form water, so we have H2O. Yes or no?
Hmm.
And this H2O shall basically come back, and this O negative is going to pull away that extra H. And thereby the final product shall look like what? The final product shall look like CH3, C, O, H is coming from back from water, and CH2 and CH2. And we have what? We have CH2, C double bond O, and CH3. So this shall be my final product, isn't it? Right?
Yes.
So this is the final product. So I have to write down the final product. So my final product shall be what? My final product shall be CH3, C, OH, and CH2, right? And CH2 and CO and CH3. And how do I name this compound? So my the naming shall be 1, 2, 3, 4, 5. So the word root shall be pent. All the carbons are having a single bond. So it is going to be pentane 2 one. Yes or no? And on the fourth carbon, we will have, OH. So I will have 4 hydroxy. But you understand this fourth carbon is also, see, this is my alpha position, this is my beta position. Why so? Because the alpha position of carbon is that carbon which is just next to C double bond O. You understand?
Yes.
So it is that position of, this is going to be the alpha position, the second carbon, right? And just next to this here, this is going to be my alpha position. This is going to be my alpha position. You understand?
Yes.
Hmm? So just next to
Yes.
alpha here shall be beta position. This shall be beta position. So just next to alpha, right?
Yes, sir.
So this is my simple aldol condensation. Got the point?
Yes, sir.
Now there could be another possibility of a cross aldol condensation. What is cross aldol condensation? In cross aldol condensation, in cross aldol condensation, I hope you're understanding that there would be two different molecules. There would be two different molecules. So that shall be my cross aldol condensation, by which by itself is also a very long topic. So you understand that cross aldol condensation basically means when two different aldol, when different aldehydes, when two different aldehydes combine to form the final aldol product, to form the final aldol product. You understand? To form the final aldol product. So that is my cross aldol condensation. You understand? So it means that when two different aldehydes it combine to form the final aldol product, that is going to be my cross aldol condensation. You understand? And here there are two types of cross aldol condensation further. That if one aldehyde has alpha H and other aldehyde does not have, And other aldehyde does not have alpha H. Does not have alpha H. You understand? And another
Yes.
type of cross aldol shall be when both the aldehydes are different. Both the aldehydes are different and both of them does not have and both of them does not have both of them have alpha H. So when you have both of them having same, when both of them have alpha H, then four products are formed. Then four final aldol products are formed. Four final aldol products are formed. You understand? Four final aldol products are formed. And here only two products shall be formed. So I hope you're understanding that in simple aldol condensation, there was only one product being formed. And here there are four products being formed. You understand my point? But this cross aldol condensation
Yes.
basically is a very, very long topic to explain that, how these two products are being formed and how these four products are exactly being formed. Understood? So I'll end my class right here today, which is going to be a 40 or 35 minutes of class, right? And that's it with the topics. And yeah, for the cross aldol, I don't know how will I do that, but 10 minutes would not be